Write a linear inequality that represents each graph. So remember, each linear inequality is bounded by a boundary line. Boundary line. And for this boundary line, we should be able to see a slope and a y-intercept. So first, I see that my y-intercept is here at 3, and my slope is down 3/1, -3. So we see our boundary lines equation. Now we look at where is the solution set to this inequality. Well, it's this yellow region here, right, that I'm overlapping in purple now. We see that for this solution, it is above the boundary line. But when we look at our boundary line, it is solid. So if we are above a solid line, that means we are greater than or equal to our boundary line. So if we summarize this into a linear inequality, we know our y values need to be greater than or equal to our boundary line, which is -3x plus 3. So since we shaded above a solid line, we were greater than or equal to our boundary line. So let's look at the next example. Our boundary line should have a slope and a y-intercept. So I can see my y-intercept is here at -3. And my slope, I go up 1, 2, 3/1, 2. So my slope is a +3/2. If I focus in on where my solution set is shaded, it's shaded here. And this is shaded above a dashed line. So if I shade above a dashed line, that is just greater than that line. So if I summarize what's happening in this shaded region, we want all y values that are greater than but not equal to our boundary line, which is 3/2x minus 3. So we want all y values greater than that line, but since it's dashed, that means we do not include the boundary line in our solution.